Hello, this is Richard Leeson, and we're back and we're going to continue on in our study 1025, our Fort Illinois, and we're going to start working on the facility load section. So we see in the details page here, everything has been completed up to this point, and now we want to hit continue to move on. The main part here is going to be in the input. We're going to select our energy focus here. Depending on what we have selected on the study information details page, if we've got energy, water, and waste, that'll show up. All we have at this point is the baseline, and so we're going to load the baseline. Now, the first time it comes up, it reads it directly from the default database, and so everything here shows red, which means it's not been saved. And we see the first thing we have to, we're going to, after we make our changes, is we want to save this. What I like to do first when I go through this is I like to see what system was selected for an existing pre-1980, or basically for that facility type for the existing, and what vintage. So I like to check that to see if I have a good starting point on my system, because that affects the energy tremendously. So we'll see that. So right now it's in an order. I know that the zone system's last, so you can sort these however you want. I just went by name here, and kind of the last thing in there is the kind of the zone information, the zone HVAC information. And we can see for this existing pre-1980 that it's selected unit heater, VAV, and VAV. And the VAV is probably not a system that is prevalent back pre-1980, depending on how old this set of buildings is. And so many times it was fan coils or even multi-zone type systems. So I'll set that to fan coil, and you can see when we change these inputs that they do change color, which allows you to quickly go through this list and see what has changed and what hasn't changed. Okay, so after I've looked at the system, and there's going to be a lot of system inputs throughout here, then I'll kind of pop back to the top and just kind of walk down through this, and I'll kind of stop on the ones that are important for us. So one of the things is the boiler efficiency and the type of boiler. Right now it's at an 80% non-condensing. We do have a lot of component information here, chill water pumps efficiency, supply temperatures. My philosophy is if you know it and it's generalized across all, everything in that facility. You got to remember, this is covering not one building but a whole class of buildings. If it's generalized across that, we want to find kind of the generalized system parameters here. And if you don't know it, then leave the defaults. And you can always come back through and refine later. And if you have to, if you've got a building that needs to be split out for some reason, you can always then split that out and refine those parameters. So anyway, we come down here, we see our condenser types, air cooled. The COP is fairly low for this chiller. It's pre-1980. There's a lot of parameters here that exist if you change some other things. So they're sitting here, but they're not necessarily active parameters. And so I'm just, like I said, I'm going to try to talk about the ones that I would look at. So I always look at the chiller COP, and I look at the boiler efficiency, and then lots of set points. But I like to look at the heating and cooling set points, because that really affects things. We see here our cooling coil type is chill water in the building with a chiller system with these set points. Domestic hot water, we have a hot water heater, and the supply temperature is set at 140. Now we also have all the equipment here, and we see that we have the equipment densities for the different areas, and these are all in watts per foot squared. So in this case, for brigade headquarters, we have a knockbox skiff area, which has a higher power density in that area, and I've seen these range, from this or a little bit lower to even quite a bit higher. So those are the types of numbers you can check if you happen to know those. If not, like I said, accept the default for now and come back and refine later. The next thing is the heating coil type, in this case hot water with a boiler, and then you have the heating set points. Those are very important to look at, because in many cases a lot of these older buildings may or may not have a setback, and in this case you see that there's a heating setback of 70, which is the same as the heating set point. In this case it did assume that. Okay, lots of system parameters, and we see the HVAC air system type is a VAV. Now we come down to our lights. This is another area that we can look at. We see what our lighting densities are in our three major spaces: our office, our knockbox, SCIF, and our mechanical room. And we do have the ability to go in and really get in detail into schedules, and this is something I wouldn't do obviously as a first cut. I'd leave this alone and leave this, because you really want comparative schedules unless you have something that you know about and you really need to change it. They are changeable, and we can talk about that as an advanced feature later. But for right now, we're just going to kind of skip over those as well. You can see we have all the schedules. They all line up with each other as they stand, in the lighting with the occupancy and the equipment, and the office schedules all line up together. That's the other reason you may, if you change one, then you have to change a lot of others as well. But then we're going to get down here to the roof parameters, and in this case we see the roof base cavity insulation. We see that the roof is insulation above deck, so we start out with a interior type of metal decking, and then we go to the insulation layer, and then on the outside we have this roof membrane. In that, we have the option of having some cavity insulation. So in the structural element there can be cavity insulation, and then mainly since it's insulation above deck, it's probably going to be sitting here as continuous insulation above this. These values are selected by the vintage, and they kind of looked at the code from that era, and we selected values for this. But this can also be customized. For example, if it was 2 inches of extruded polystyrene, that would be about an R10 sitting in there. And then we move on to the wall parameters down here. Once again, we have the cavity, the base continuous. This one was a the base wall was a concrete block, solid grouted, with gypsum on the inside and stucco on the outside. And as you can see, there's different sidings in, and different sidings are different base types, as well as different interior types. So it's either kind of like none or a 1/2 or 5/8 inch gypsum. The finish inside and out isn't as important as the it's kind of the base type, whether it's block or wood framed or steel framed, and the insulation. But it's also it's something that can be changed and looked at. And then finally, we have the window SHGC and the U value. And the U value, like I said, these are all by vintage and by climate zone. We're looking at a 5A climate zone here for Fort Illinois, and so the U value is moderate for pre-1980. This is an older double pane window with with the SHGC at 0.4. So a single pane would be about a 1.22 U value, so we know it's double. And modern windows are coming in at 0.3 and lower. And high performance triple panes they're trying to get down to 0.25, 0.2, 0.15, and the magic number they'd like to get to is 0.1, or about an R10 if you take the reciprocal of that. And then we're kind of back here to our fan coil air. So we basically would come through and do that for all of these, and what I do instead of having to hit this every time is I hit save changes, hit that save changes right here, let that go out and write that to the database, and then every single time we come back to this page, it'll reload that from the database, and it'll reload it in this alpha. So we see right here that it's green now, which means it has been saved here, and you can see that it's been reread back in alpha order. So we can quickly go through this and determine our. I'm just going to look at the what this is, and look at changing this. That's a pre 1980. I'd probably go with the fan coil, the DFAC, the rooftop, and that's going to be fine. This is a general instruction building. It's kind of an army instruction, not a school, but an army instruction building. It's also pre 1980, and that covers that covers the 50s, 60s, 70s type buildings. And so that they weren't all that energy efficient back there, and it's definitely probably not a VAV. So we'll go with something like a VAV multi-zone. Then we'll go to a hotel large and PTACs. PTACs are kind of through the wall units, and back post 1980, not a large. That's more for medium size to small. They can be, but there's still a lot of fan coils in larger hotels, and so I'm going to go with that. And of course, like I said, it can be adjusted to whatever you actually have on site. This one says an existing pre with fan coils looks good. Office medium existing pre. That's a fan coil, looks good. Office small, and this is probably going to end up being a rooftop unit. Yeah. This is a health center, and it was a pre 1980. Probably more like a VAV multi-zone. Physical fitness center. Constant air volume. CAV reheat, probably right. This is a school post 1980, and so yep, that would probably be good for that. Secondary pre 1980, so it's getting a little. Those are getting to be older schools. And rooftops and this, and the only one I question is this one and temp rooftop or a package unit. Either those are really the same thing. They can sit on the ground next to it or sitting there. Fan coil for a pre, looks good. Warehouse demolished mid-century, so this is old stuff, and it's some type of package unit. And got demolished warehouse, and finally the rooftop unit. Now, at this point, we've kind of walked through all these. We could have changed any in all of those. So this is just kind of the initial big picture walkthrough. We can hit save changes, and it will definitely save the changes. But I also want to show you if we hit continue and we haven't, it will save the changes. Now, the one thing that would not get this saved is if you went up here and clicked on another button directly and left the page without hitting continue or save. Then you lost all your changes. And so at this point, we come to our simulation page, and we see that we got 17 simulations. So we had 17 facility groups. Now we had 24 total, but some of those were planned. So those are not there in the baseline. So we only have the existing and demolished buildings here at this point. And so while we're talking about that, we hit, this is the simulate button, this is the refresh button, this is the reset, and it walks through all those, goes out and checks those, and see we've got 5 are sitting there running right away. We got 12 queued. Give it a few more seconds, refresh it, and we have all 17 are running. So it goes out to the job server. The job server accepts these or queues them, and it's got quite a few processors, and you can see right here it's running all 17 at once. And so at this point, I let this kind of run a minute or two and then hit refresh, and you just do that. And we're going to go and let this run, and we're going to stop this, and then we'll come back and pick up from there.